In a previous video, I discussed simple sugars. These are monosaccharides and disaccharides. In this video, we're going to talk about polysaccharides, also known as complex carbohydrates. These polysaccharides can be used to store energy, and they can also be used for structural support within plants. We're going to first tackle the energy storage function of polysaccharides. A polysaccharide consists of many monosaccharides covalently bonded to one another. The prefix poly means many, and saccharide means carbohydrate unit. So again, we've talked about this previously. So all carbohydrates have the chemical formula C subscript N, H subscript 2N, and O subscript N. In animals, glucose monomers are joined together to form a polymer called glycogen. And so you can see here, glycogen is a branched polymer of glucose. And it's very important for energy storage. So let's imagine, for example, if you have a meal, as you digest the food, you'll break it down into the complex molecules down into simple monosaccharides, such as glucose and fructose and so forth. You can absorb those into your blood. And typically after a meal, you'll have a spike in glucose. So the glucose levels will go up in your blood very high. But the glucose actually will be taken up by muscle cells, and it will be stored as glycogen, which is, again, this polymer of glucose. So glucose is the monomer. The polymer is glycogen, which is highly branched. So you'll have these glycogen granules. So for example, you can see here a picture here of glycogen granules that are stained blue in an animal cell. It turns out your liver is also a storage place for glucose. So glucose is taken in as glucose monomers into your liver cells, and within the liver cells it's converted to glycogen and then stored there. And then in between meals, as your glucose levels in your blood decrease, well, you need to replenish that glucose. And that glucose primarily comes from these liver cells converting glycogen back into glucose and then releasing it into the space around the liver cells. And then from there, it gets into the blood, and then that supplies you with energy for your cells. So glycogen is the storage molecule for carbohydrates within animals. And that helps us maintain a certain level of energy. Now in plants don't use glycogen. They use a different polymer of glucose. In plants, glucose monomers are joined together into a slightly different form to form a polymer called starch. And starch is the main energy storage carbohydrate in plants. So for example, here I've scanned a picture of a bag of potato starch. You can see if you look at the ingredients that there's no fat, there's no cholesterol. But if you look at carbohydrate, you can see 10 grams would be 4% of your carbohydrates for the day. So it's essentially all carbohydrates when you have potato starch, and this starch is actually glucose. So if you were to eat some potato starch, you'll have a process of digestion in which you break the starch down into glucose. You're then able to absorb the glucose across the wall of the small intestine. It then ends up in your blood, and it's converted into glycogen within your muscle cells and also within your liver cells, as I just discussed. Now, carbohydrates aren't just used for energy. Carbohydrates also provide structural support in plants. Unlike glycogen and starch, cellulose is insoluble in water. This means that it does not dissolve in water. So cellulose is the main constituent of plant cell walls, and it also makes up vegetable fibers such as cotton. Fruits and vegetables are a very rich source of cellulose. Cellulose cannot be digested by humans, but it is important in our diet. So cellulose in food is one type of dietary fiber. Cellulose encourages the movement of food through the intestines, thus helping to prevent constipation, and it prevents irregularity. Cellulose is known to reduce the risk of colon cancer. We don't know exactly why this is, but one idea is that if the contents of the colon move faster through the system, that's good, and you don't have these toxins very long within the digestive system, and therefore that might be the reason why there's a lower risk for colon cancer. Finally, fiber-rich foods, which have a lot of cellulose, help a person maintain a healthy body weight. The reason for this is because we can't digest cellulose. It tends to, it fills up our stomach and so forth, and we feel more satiated, more full for longer. So there's a lot of good things to say about cellulose, even though we can't actually break it down ourselves to use for energy. Okay, that's all I really wanted to say about this, and we're going to move on in the next video and talk about more biomolecules. Thanks very much for watching.